Science 10, and welcome to part B of lesson 9 on how to name polyatomics and multivalents. Today we are starting on page 19, naming cations with stock systems. So you're going backwards in your notes from your last video, and we're going to start page 19. So in this lesson, you learned how to create compounds that required using Roman numerals. We call these multivalent. And we're going to learn how to name multivalent ions by looking at chemical formula. Oh, sorry, we're at the back of the presentation. Let's start by the front. Let's try this again. So on your periodic table, the highlighted section on this periodic table, those yellow compounds in the middle, those are the ones we are talking about. Okay, your polyatomics are found up here in the polyatomic table on your periodic table. You got your non-metals, you got your metals over here, and you got your non-metals over here. These guys are metals as well, except we give them a little special name. The special name is called the transition metals, and this is because not every single metal is stable with one configuration, meaning they can have multiple different energy levels with electrons on them. We call these metals transition metals because they have two different forms, or essentially they have two different charges. So when you look at them on the periodic table, you'll notice most of them, like iron, has a charge of, I think, 2+ and 3+. That makes them transition metals. They can have a couple different configurations. So in order to do this, in order to show which ion it is, they have a couple different ways because, well, not a couple different ways, sorry. We have one way to do it because they have a couple different chemical properties. So if you have iron 2 versus iron 3, or nickel 2 versus nickel 4, I can't remember if nickel's 4 or not, but essentially it just means that they have different chemical properties. So we have a very important way of naming it so you know which one you're talking about. So what we do is we use Roman numeral numbers to correspond to the charge of the cation in the bracket after the cation name. Now you're probably thinking, what is she talking about? Essentially, you're going to look at the charge and then you're going to say, oh, it's 2+. I need Roman numeral number 2. Oh, it's 4+. I'm going to need Roman numeral number 4. So these are the Roman numerals right here. I will not give you all of them on a test. I will only give you some. So you're going to have to start really practicing with the name, looking what they look like. 1, 2, 3, 4, 5 are the most common ones we're going to use. You probably will not see 6 through 10. So I would start memorizing 1 through 5. So an example, like I said earlier, iron. There's iron 2 and iron 3. So when we look at iron and it creates an ionic compound, a metal and a nonmetal coming together, you can see right there that iron 2 oxide means that this is the compound that it looks like, FeO. That's because it has a charge of 2+ and a charge of 2-. So they balance out, they make a neutral atom, a neutral molecule of 0. There's no charge. So it's just written like that. However, if I gave you iron 3 oxide, so you can see here the iron 3's in the brackets, that's a little bit of a different story because this is now +3 and this is now -2. They don't balance out. And we now know with ionic charges that they need to make a 0. So what we do is we say there has to be 2 atoms of iron and 3 atoms of oxygen in order to balance out the chemical equation of iron 3 oxide. Now this is key. If there is Roman numerals in brackets, do not write the Roman numerals in the compound. So here it is written out. Do not take this iron 3, don't take this 3 and shove it right here. Okay, that's not what it's for. It's only for when you read it, so you know which one you need to use. Okay, this tells me I need to look at iron 3+. This one tells me I need to look at iron 2+. I don't need these when I balance this. I just use the charges that are on the periodic table. So I don't need the Roman numerals in the chemical formula. So on the periodic table, the most common charge for an ion is listed first. So for iron, for example, 2 is listed first. So it's the most common way you would find iron. Okay. If you look at all your multivalents, there's a lot of varieties of multivalents. Whatever number comes first for the charge is the one it is most commonly known as. If I give you a question on a test that says, what is iron? Iron and something come together to form an iron compound. Yeah, that's really helpful. Hey, I just said iron 4 times. If I don't give you a specific number like iron 2 or iron 3, you can just assume I'm talking about the most common one, just like we did with isotopes and ions. Okay, if I gave you a certain, or sorry, when we were talking nuclear notation, if I give you something that I don't specify, just assume it's the most common one on the periodic table. So for example, manganese fluoride. If I said, there's a compound of manganese fluoride, what does it make when it comes together with blank? Manganese actually has 2 charges, 2 plus and 4 plus. You can assume, if I didn't tell you which one it is, you can just assume that I mean the most common one, which is this one right here, 2 plus. So fluoride is 1 negative, so you would then just write MnF2. It's an ionic compound, so I'm going to go solid. So you see, I didn't even worry about the Roman numerals in this case because it didn't give it to me. If it had given it to me, it would have been right here. So it would have said manganese 2, it's supposed to be a 2, fluoride. It would be right here if it did. But because it didn't, I just assume it means the most common charge. Again, how did I get this? Mn has a charge, we guessed, because we are like most common, 2 plus, and fluoride has a charge of 1 negative. So we want to balance this out by saying, okay, 2 is bigger than negative 1. I'm going to add 1 more here. Now I have 2 negatives to 2 positives, and I have a 0 charge overall. So again, in this lesson, you learned about compounds that required Roman numerals, and you learned kind of how to name them. All right. If we go back, okay, you would take, again, putting the Roman numeral right in here. So if I gave you this, it would be iron 2. If I gave you this, it'd be iron 3. Now you're probably thinking, I don't know how to do any of this, but that is okay because we will practice, 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 practice. So once your notes are in your thing, if you have any questions, please let me know.